Good morning, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin today's session, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome Saurav, our speaker for today's session. Saurav is a cloud solutions architect at Microsoft and is passionate about contributing to the community through tech sessions. He is also a researcher and a hackathon enthusiast. But for now, I will hand over to Saurav to begin the session. Let me bring him into the stream. There you
Hi
go.
Rashmita,
Your- Hi, Saurav. How are you doing this morning?
doing good. How are you?
I'm doing absolutely good. Thank you so much.
I'm so excited to
Your
see the audience
presentation
back
is
over
up
here.
and the floor is all yours.
Thank you so much. Hey everyone, I'm so happy and glad to connect with you again and talking about our series that is Mastering AZ104 with Saurav. As a part of the series, we have already covered identity and governance. We have talked about storage. We have come a long journey. We have talked about compute. And today is where we talk about networking. If you remember in the last session, we already talked and briefed you about the basics of networking being a huge or a vast topic. Today, we'll go into the more advanced part of it and we'll have hands on demonstrations. So, I'm really excited to get started with you all. 1 minute. Okay. So in the last session, we had already explored about Azure Virtual Networks, and we understood that virtual networks are just like a virtual representation of your logical or the physical network that is hosted on Azure data centers, right? And these Azure network is available worldwide globally. So again, you can create your virtual networks, you can host your resources or services or resources on a particular network, and you can access it via that network, right? Now we also understood a concept of a CIDR range, right, which is the set of private IP addresses that you assign to a virtual network. When we talk about Azure Virtual Network, it's always a private virtual network or an isolation of a private virtual network that is being created for you. We also talked about something called as subnets. And what is a subnet? So we talked about subnet being a sublogical layer within the virtual network that wherein again you define a CID range. You can subnet has its own use cases where you can tag or you can assign or associate a network security group to a subnet. And what is a network security group? We talked about network security groups as a set of rules that allows us to filter what sort of traffic that we want inbound and outbound towards our virtual network, right? So again, network security groups can be associated at two levels, either at a subnet level or it can be also assigned to a network interface of a VM, right? So with this, you have the capability to filter out the traffic not only at a subnet level, but also filter out traffic that is coming inbound or outbound to, across your VMs as well. Now, we also demonstrated how you create inbound security rules or outbound security rules, wherein you provide a priority number. The lesser the priority number, the more higher is the precedence. You provide a name, you provide a port, a protocol, the source protocol, and the source IP address range, a destination set of IP address range, and what is the action that you want to do? Do you want to allow or deny? Right now, by default in a network security group, everything is created to be, all the traffics are made to be denied by default. Now if in case you want to allow a set of traffics to your resources, you want to define an allow rule for that particular traffic. What is the application security group? We also talked about application security group, which serves a common need. Let's say a set of VMs running in a web cluster, okay, and all of those VMs serving a set of use cases, on a similar set of use cases. Let's say it's a web hosting for my web app, or it's an app hosting wherein it hosts APIs. I can cluster them together into a single application security group, and I can create rules on that application source security group as tagging it as a source or a destination. Now, what is the problem that it solves for me? Now, I do not have to create separate rules for each of the VMs that I have within this particular cluster. Rather, I'll create a single rule that is associated with the application security group, and all of the VMs will follow, or the traffic, to all of the VMs will follow those rules, right? Uh, Now, coming to the topic of interest for today, we'll want to talk about more about Azure DNS and what it has to provide. We'll talk about virtual network peering and much more stuff. So, without much ado, we'll get started with today's topic. So, first of all, what do we understand by a domain name server? And DNS, right? So DNS is where you can host your domains, and you can define records or rule sets that your domain name needs to follow. Right, there would be some name server records, there would be some SOA records and stuff like that. Now, what is Azure DNS? Azure DNS allows you to host and manage your own domain. What does this mean? So basically, you can create your name records or name server records that can map to your domain names. Now, does this mean that Azure provides its own domains, or does the DNS as a service provides you a domain? Well, you do not uh, get to create your own domain or register a domain via this Azure DNS as a service, where there is a different service that you can use to register a domain, or you can use a already registered domain from any other third-party domain registrar, and you can associate it with the Azure DNS zone. We'll show that in just a minute on how you can create an Azure DNS. Now, I'll just quickly go to my Azure portal, and I'll just quickly show you. I hope the screen is visible to you. So I'll just quickly go and I'll show you how do I create a DNS zone. So on the global search bar, I'll just type in DNS. And so there are two types of DNS zones. It could be a public DNS zone, which is the usual scenario, or you can also create something called as private DNS zones as well. Now imagine a specific scenario. You want to route the traffic from a private endpoint to some other resources. Okay, you want to map it to some other name server. So that is where you use a private DNS. Now let me quickly create a DNS zone, and I'll show you quickly how does it look like. So I choose my subscription, and as already said, every resources on Azure needs to be in a subscription and a resource group, and that's where I define my resource group. Let me just create or look up for a resource group is network. Okay, I'll choose network RG, and I'll define a name for my domain name system, AZ104 DNS. Yeah, and I will define. It should be always lowercase, but I can just quickly correct it. Yeah. Now I'll go ahead and I'll create a zone editor. I can provide my own DNS zone files over here. I'll just skip it for now, and I'll go ahead and create the resource. I can provide the required tags, and I'll wait for the validation to complete. And here I go. I'll create my deployment. Once done, we'll wait for it, and I'll quickly show you how do you edit the name server records, how do you create records within it. It could be a AAA record as well. It could be a SOA record. So this is my DNS zone, and if you quickly see over here, the name of the DNS zone is AzureDNS.com. I'll quickly just show you 1 minute. So loading up, okay, and as you see, the maximum number of record sets is 10,000, and the name server that you see over here that is associated to my DNS. Okay, now I'm interested to create some records. Okay, so DNS records. So you already see there are name server records, there are SOA records that are linked to my domain, which is azure.dns.com. I can further add on any record sets to my records. Okay, I can define a name, let's say uh, and I define the type. Is it the 4A records, or is it a CAC name and stuff like that? I can create a basic text record. I will define the value as DNS, okay, and add. So this is how you simply manage your DNS on Azure, right? Having said that, let's get back to our topic and explore the next. We talked about Azure DNS. What's next? So we are interested in also understanding how do we connect two different virtual networks. We talked about virtual networks being isolated logical segregation of your entire virtual network, right, which is available globally. Now, imagine
Saurav,
there are two logical segregated. Yeah. Mhm.
Saurav, can you reshare your screen one more time? I think people can't see your screen.
Okay, I'll quickly share it. 1 minute. Were you able to see the demo by any chance?
I think no. People are asking, are you giving demo?
Oh,
Uh, I think they were just able to see your screen, or some they were not able to see at all.
okay. I'll just quickly
So
cover
right
that.
now
Maybe
we
then.
can see.
Mhm.
Yeah,
I'll quickly maybe.
yeah,
Do you
yeah,
see
yeah,
the
yeah.
Azure
Now we
portal,
can
right?
see the
Okay.
demo screen. Yeah.
Great,
Yes,
no
yes.
problem. So I'll quickly just demonstrate how it looks like when you create a DNS record for that. And pardon me, I was not really aware about it. Was it not shared? So here within the DNS zones, you can just type in the global search bar on your Azure portal. For the people who are from the academic background, a quick reminder that you can create your own free Azure account by just going to Azure Students for free. This is something that we already discussed, but for people who are not aware, you can just go ahead. You can get $100 for 12 months, which is much more enough to carry out your personal projects on Azure. You can sign up for that, and you just need an academic record to be presented, and that's where you get access to the Azure portal, right? So once you're on Azure, I mean, just type in DNS. So as already shared, right? I mean, there could be two DNS, one a public one, which is Azure DNS zones, or you can also create a private DNS zone. Private DNS zones are usually when you have a private endpoint being linked to a name server record. Okay, so we are interested to show you a DNS zone. How does it look? I'll not create one. I'll just quickly show you how does it look to create an Azure DNS zone. You just need to provide the subscription or resource group, which is the container level. I mean, both the subscription and the resource are the containers for, or your an encapsulation of the resources. You provide the resource group name, and then you provide the domain that you want to register. Okay, so the domain should already be registered with you. You're creating an Azure DNS zone, which means you are linking the domain to a particular name server and stuff like that. You provide the name over here, and then you can go to the zone editor. You can provide any DNS zone files. I'll go with the empty now, and I'll provide the tags which are metadata, and I'll review and create. Now, once I have already created my DNS zone, how does it look like? I'll just quickly show you. So I created this Azure DNS zone. And if you see over here, there are maximum number of records that I keep is 10,000. The name servers that, I mean, these are already registered to my domain, or DNS, okay? And here is where I am really interested to show you. So you can create your own records within the record sets. Now imagine I just registered a domain which is called as azure.dns.com, right? And I want to link it to a name server on Azure, maybe some resources on Azure and stuff like that. So that's where I can create a record set to link it. Just giving it a minute to open up. Now you see the name records, right? So again, Azure DNS.com is linked to these name server records, if you see over here. And then there is an SOI record that is again created. I also showed how you create a TXT record as well. You can just go ahead over here and add. You can provide a record name. Just quickly show it. There's some network, latency from my side. Sorry for that. So you can provide a name to your record, and what sort of a record do you want to create? Is it an MX, a mail server, a text records, IPv6 or IPv4 record, or a CNAME record and stuff like that. Let's say you want to link it to a subdomain, so you create a CNAME record then you provide the other details like TTL unit, and any IP addresses that you want to link it to. So this simple, and just think about a VM that you need to link to an IP address, right? Or maybe an app service that you want to link to an IP service of your, or a domain name of your own, and that's where you create an IPv4 address record. You provide the specific IP address of that app service, and you link it to that domain. So as simple as that. If you have any questions, feel free to reach out on the chat, and I'll be happy to answer that. But we talked about the Azure DNS, right? And what is the next thing that we are really interested to talk about? We're interested to talk about virtual network peering and VPN gateway. So I talked about two specific scenarios, right? I have VNet on Azure being created in one of the regions, let's Central India, and some other VNet being created either in Central India or some other region, let's say South India. Think about one more scenario. I want to connect my VNet, which is in Central India, to a region that is my on-premise region. Imagine like this: you have an office network that is located at your on-premise, and you want to connect it to Azure VNet. How do you do so? And that's where the concept of VNet peering and VPN gateway comes in. So we'll first talk about VNet peering. What does a VNet peering mean? VNet peering allows you to connect any two Azure virtual networks between each other, which means when you peer two virtual networks, you allow communication across that two virtual network. So resources in one of the virtual network can communicate to resource in the other virtual network, and vice versa. Now there are two types of virtual network peering that is allowed on Azure. Either it can be regional peering or it could be a global peering. If you see on the doc in the PPT as well in the slides, just quickly show you how does it look. So if you have two virtual networks in the same region, which means you peer it within the same region, it's called as a regional peering or a local peering. When you peer two virtual networks across two regions, which is again possible, you term it as a global virtual network peering. And there's slight difference between the two, which we'll discuss at a later point in time for sure. Okay. Now, what is that you can do with this virtual network peering? You can peer any two virtual networks on Azure. You can also peer a virtual network which is in a China cloud or maybe Azure government cloud. These are two other variants specifically meant for government organizations, keeping in mind their the specific needs, right? Again, how does a regional peering work differently from a global peering, and what is that is the difference between the two? Now think about a regional peering. The traffic only traverses between within a single region, right? And that is where a local peering is configured. While in a global peering, the the traffic is moving across region. So there is a cross region data transfer cost as well when you have a global peering. So it is always better, it's always suggested when you want to peer two networks, unless until really required, you should configure local peering than a global peering. Okay. Now, I see a question over here by Jeff. How can we integrate with other domains like GoDaddy or third-party DNS? Yes, Jeff, you're correct. Let's say you already registered DNS, a domain on GoDaddy or any other third-party provider. You can link it to Azure DNS. Sorry, you can link to any resource on Azure using Azure DNS, and that is where the domain name server, is available as a service to you, right? Imagine you want to link a domain, which is, let's say, sauravbera.com, to an app service or maybe a virtual machine, okay, which has an IP. So you want to link the public IP of that VM to the domain using a DNS record, right? And this is where you will be able to integrate a domain and a service together, so that the whenever the domain is hit, the IP address of that service is being called out, and that should be a public IP address. Similarly, you have something for private DNS as well. Private DNS are created for a particular virtual network, and it's linked to a private endpoint, or maybe a private endpoint, rather, a private DNS link. So yeah. So having said that, I'll quickly show you how does a virtual network peering happens, okay, and what is something that we achieve using virtual network peering. So you already understood, right? Virtual network peering allows you to connect to virtual networks. Now I'll quickly show you a demonstration of the same. I'll go to my virtual networks and I'll select my subscription of interest. All of these are a sandbox environment. So over here, if you see, there are all of the virtual networks are in Central India. Let me quickly create a virtual network which is across a region. Okay, I'll create a global peering. So let me select my resource group. My VNet, I'll create SI VNet, yeah, it's a South India VNet, and I'll create it in South India. Next, I'll go by the default for now. I'll go ahead over here. And so one important thing over here when you create a VNet is your VNet address range cannot overlap, which means if you have configured a CID range of 10.0.0.0/16, it will, the IP addresses range from, the set of IP addresses that you see over here, the other VNet that you want to peer cannot have the same set of or an overlapping set of IP address range. Why? Because obviously when you are interlinking the two of the, or integrating the two of the virtual networks, and you query a particular IP address, a private IP, it does not know where to query, because both of the IP address could be present in either of the virtual networks. So that is where there could be no overlap when you configure a virtual network with the two virtual networks with a peering. Okay, so and that's where I'll go ahead and I will create a VNet with a different set of virtual networks. Okay, different set of CID range. I define the subnet range as /24, and which looks good to me. I'll go ahead and create the virtual network. Okay. Now we are ready to create a virtual network peering, right? So let me just quickly show it to you. Allowing it a minute to complete the deployment. Meanwhile, I'll quickly select the virtual network that we want to peer. So we already create a VNet in South India region, which is SI VNet, and there is my VNet which I created last in the demonstration, which is in Central India region, right? So I'll just try peering the two networks. So I'll go to my VNet over here, and I'll go to the peering, which is your virtual network peering. Okay. And I'll create a thread and add a new peering between the two virtual networks. Now, what are the different configurations that I want to provide over here? So I want to provide the peering name, which is my VNet to SI VNet. Okay. And the virtual network deployment model is resource manager. I'll select the next VNet, which is SI VNet, which is in Azure Network RG. And what sort of communication that I want to allow? Do I want to allow all set of communications, or do I want to allow specific set of communications between the two virtual network that is peered? So you see over here, allow SI VNet to access my VNet. Okay, which is okay. I want to allow SI VNet to receive forwarded traffic from my VNet. Okay. Allow gateway or route server in SI VNet to forward traffic to my VNet, which means any gateway or route server in SI VNet to forward traffic to the my VNet, in which is in central India. And enable for this, you will obviously have to have some VPN gateway or a route server. Okay. Enable SI VNet to use my VNet as a remote gateway or a route server. Again, this would also require a gateway in the my VNet virtual network, and we'll talk about those VPN gateways as we go ahead. Okay, so now I'll allow both of the traffic communications from the two network, and I'll give it the local virtual network summary. Okay, the peering link name on the remote. So this is my remote virtual network. I'll just need to change the name. It will be SI VNet to my VNet because it is a remote network connectivity, and the other one should be my VNet because that is a local connectivity from my VNet to SI VNet. Okay. I hope this is not that confusing. It's a bit difficult to understand, but yes, feel free to ask your questions and I'll be happy to. So again, I allow a bi-directional communication between the two VNets, which is allow my VNet to access SI VNet and also allow my VNet to receive forwarded traffic from SI VNet, right? So I'll go ahead and add, and let's see if the peering is complete. Now, once the peering is complete, what is something that we can achieve out of it? Any resource, let's say a VM, which is sitting in my VNet, can communicate to the SI VNet, while at the same time, any resource on the SI VNet can also communicate to my VNet. And this is what we achieve via VNet peering, the VNet linking, right? I'll quickly show you how does it quickly show up. So peering sync status fully synchronized, peering status connected. I'll go to my remote virtual network, and I should also be able to see the peering listed over here to my VNet. I'll quickly show you that. Okay, so you see SI VNet to my VNet. So I mean SI VNet, which is sitting over here in South India region, to my VNet that is in Central India is also connected. I mean it's a bi-directional connectivity between the virtual network peering through the virtual network peering, right? Now, having said that, we already set up the virtual network peering. We know that we know now can connect two virtual networks. But how do we connect a virtual network to a non-Azure virtual network? Non-Azure virtual network, what do we mean by that? Non-Azure virtual network, I mean, when I say a non-Azure network, means it could be an on-premise network, it could be some office network, it could be also your home network as well, right? For this, obviously, in a home network, you would need a route. A VPN gateway or a route server that can connect to your Azure virtual network, right? Now, that's where VPN gateway comes in. So VPN gateway is like a connectivity from your Azure VNet to a non-Azure VNet, right? Any non-Azure VNet to Azure VNet connectivity is established using a VPN gateway or something that is also called as express route. Express route is a different topic and we will not discuss it over here, but I will talk about VPN gateway again, I mean in detail. Now, VPN gateways are of multiple types. You can create a site-to-site VPN connectivity, which means an Azure site to an on-premise site. You can also use it for a VNet to VNet connection as well. Okay, so which means you have an Azure VNet, and you can also connect another Azure VNet as well using VPN connectivity. That's again possible. But a very typical use case, a point to site connectivity. Just imagine an Azure site and you want to connect a particular user in your on premise, let's say your machine, to Azure virtual network using a point to site connectivity. So these are the three different scenarios: a site to site, VNet to VNet, and a point to site. Okay. Now, uh, a VPN gateway is like an IPsec. I mean, is an IPsec tunnel. You can think of it as a secure. I mean, a virtualized private tunnel being created for you over the backbone internet, which can allow communication via your on-premise site to Azure, right? And again, this has multiple benefits. Think of a customer who has on-premise machines and wants to connect to Azure to perform certain actions, or I mean, it should not be over the public internet for sure, and you wants it to be private, right? And that's where you can use a VPN gateway as a connectivity option or an IPsec tunnel. You can for this. Okay, one important thing for an IPsec tunnel to connect to your on-premise site, you always need a VPN gateway. A VPN gateway uh, is your gateway at Azure end, and similarly, you would also have a gateway at your on-premise side. And this IPsec tunnel is connecting via the two gateways that are available in your virtual network and your on-premise side. Uh, this is a secure way to connect over the public internet, while you also have one more option, which is an express route. What does an express route mean? Express route means that you leverage your ISP provider, your internet service provider, to create a dedicated tunnel between, not a tunnel, a dedicated network connectivity path between your Azure virtual network to your on-premise. The VPN gateway is something over internet. Okay, while an express route is a dedicated tunnel, which means it's a more costlier because it's a dedicated path being set up for you, and it is much more secure as well. So, having said that, we'll now move to the next topic of interest, which is Azure load balancers and application gateway. Well, I'm pretty sure. I mean, you would have heard about load balancers, and you would have worked with some of the other load balancers, right? There are multiple load balancers. There are web load balancers. There would be TCP and UDP load balancers, or the layer 4 load balancers that you would have worked upon. Now, how does Azure provide those load balancers? Now, you typically, when you talk about load balancers on Azure, there are four different offerings, but we are interested to talk about two. I'll just quickly name each of them. So you have Azure load balancer, you have application gateways, you have traffic manager, and Azure front door. Now over here we'll talk about, or we'll primarily focus on Azure load balancer and application gateway, while the traffic manager and the Azure front door are much more advanced, which are global load balancers. Okay. Now, what is Azure load balancer? Let's talk about the first and the most basic load balancer type that is available on Azure, and I'll also show it by the demonstration. Now, Azure load balancer is a layer 4 load balancer. Which, what does it mean? When you say layer 4 load balancer, which means it can handle any TCP or UDP connections. Okay. At the layer 4 of the network. Now it can act as a private, or it can act as a public load balancer as well. Ideally, Azure load balancers are typically served for a private load balancer use case over here, which you see as an internal load balancer, or even a public load balancer as well, which means it would have a public IP and it can load balance the traffic to a set of virtual machines which are acting in the backend. Now, how does configuring a load balancer look like? So you would have to have some front end IP if it's a public load balancer. If it's a private load balancer, even then you would have a private IP at the front end. You would have to have some load balancing rules, which defines how do you want to route the traffic from that comes through your Azure load balancer to the backend pools. Backend pools refers to the set of VMs or any other resource that you want to route the traffic to. Okay, you obviously need a backend set of backend pools. It could be one single VM, it could be multiple other VMs. You need to have health probes which checks the health status of the backend pools. Obviously, imagine of a scenario, one of the VMs in the backend pool is not available, and the load balancer keeps on routing the traffic to that particular VM. You don't want this scenario because it's not responding, right? It's not responsive. In that case, health probes are really helpful, wherein the health probes can track the health status of the backend pool. And let's say one of the VM is down. One of the VM is down. Let me just quickly show it that to you. So one of the VMs are is down. You can directly, the load balancer can direct the traffic to the other available VMs, right? There would be an IP over here, either public or a private IP. Over here, if it's a public load balancer, you would have a public IP. You would have some routing rules to define how the traffic should be routed. And similarly, you would have some NAT rules as well in case you need some NAT. NAT is network address translation, right? You want to define you want to change the source or the destination IP address, and that's where you use the NAT. And you obviously need some outbound rules as well. Okay, so let me quickly show you how do you create a load balancer on Azure, a basic Azure load balancer. Okay, so I get back to my Azure portal, and I'll go to my home, and I'll type in. Let me quickly show you what a load balancer does look like. So load balancers. One minute. So you see, on Azure, as I already talked, Azure, the different load balancing services that are available with you. One is your basic Azure load balancer. You have an application gateway, which we'll talk about. You have front door and CDN profiles and traffic manager. Front door and CDN profiles are global load balancers, while application gateway and load balancers, basic load balancer is a regional load balancer. Okay, so I'll quickly go ahead and create a load balancer. I'll quickly show you how does a load balancer look like. So in this scenario, I'll create a public load balancer. Okay, I'll just quickly select my same network. I'll give it a name as public VM, public net VM LB, which stands for load balancer. And then I'll define my region where I want to store. Since it's a regional service, every resources on Azure needs to be designated to a particular region, even if it's a global load balancer as well. The SKU could be a gateway, a standard, or a basic. Basic is retiring, so we'll use a standard. And then we define the type of the load balancer. I'll choose it as a public. I can choose a regional or a global load balancer, and then I'll choose go to the front end IP configuration. So I'll just need a front end IP to which my traffic would come. So I'll define our IP over here. One minute. Okay, I'll give it a name as Azure ACV Net VM LBPIP. Okay, and it's an IPv4 address, IP address. Select an IP address or create a new. I'll give it a name as. Sorry. It should be a standard one, a zone redundant, and just fine. I don't need a gateway load balancer, and I'll give it a name front end configuration as. Yeah. Okay, so I'll go to the backend pools. Now I want to define what is the load balancer would direct the traffic to. What are my backend pools? So it could be a set of resources on Azure. It could be, let's say, backend pool name. I'll give it a name as VM backend pool. Oops. and select the virtual network that I want to. So I don't remember. I think this is where my virtual networks would be. And okay, IP configuration that matches the above criteria. Let me check for any IP addresses. I do not have it. Okay, I'll just select one of the VNet which I know hosts certain virtual machines or IPs. Let's say this. Okay, and I'll select the resource over here, which will act as my backend pool, which means the load balancer will redirect the traffic to this particular resource or the set of resource. Oops, I do not have any resource. It looks like my sandbox environment does not have much resources. So I am assigning a backend address, which is of my a VM Azure Arcbox client. Okay, and there's an IP address. I'll currently define only single IP address. I do not think I have any other backend over here. So I'll just define a single backend pool. Okay, and then I'll define the inbound rules. Okay, so you can define a load balancing rule, which means how do you want to redirect the traffic to. Meanwhile, I'll quickly answer the question by Shivaguru. So, when we create a DNS zone in one particular subscription, will that be able to communicate with other subscription and also to the other cloud providers? Well, that's a good question. So, think about it as like this: DNS zones are your network zones, right? It's a public DNS zone. It will be available across other subscriptions or any other cloud providers as well. It's a private DNS zone. Private DNS zone is linked to the particular virtual network. It's not linked to a, I mean, it's always contained within the subscription, but think of it as a private DNS zone is always linked to a virtual network. So any resource within that virtual network or an extended virtual network can communicate to that private DNS zone, but anything beyond that virtual network cannot. I hope that answers your question. So I'll give it a name as LB rule, just to keep it simple. Okay, and I'll define my front-end IP, which is my front-end IP I created, a backend pool as this, and I want to define what is the port that I want to direct the traffic to. So let's say it's a HTTP port. Okay, I mean, if the traffic comes from a HTTP port, I want to move it to, let's say, 8080. Okay, and session persistence, which is fine, and outbound source extent. So I'll save this. Okay, I want to also create a help probe. Sorry, LB health probe, giving some name. Okay, save it, and I should be able to create the load balancing rule. I can also define inbound route rule, but I'll skip it for now. I can also define outbound NAT rules, and I'll go ahead and create the load balancer. Now, this is a specific scenario when I created a public load balancer. You can also create a private or a internal load balancer as well as per your need. Okay. Okay, I'll just quickly show how things look like once you've created it. So there is a public friend in the printed IP configuration. We have defined a public IP, okay, to this particular load balancer. 1 minute. Okay, so when you go to the front-end IP configuration, I have defined a particular public IP, which is my public IP, wherein I want to hit the load balancer. Then it directs the traffic to the backend pools. It could be a single backend pool. It could be a set of resources in the backend pools. Okay. Now you also define a rule or a, I mean, load balancing rule on how do you want to direct the traffic when the traffic hits the load balancer. Okay. You can also define inbound NAT rules. You can define outbound rules in terms of how does the traffic from your resources goes through the load balancer to the external maybe network. Okay. So over here, I've defined the VM backend pool. Oops, the name looks really weird. Okay, so and that's how you create a internal or sorry, an Azure load balancer. Okay. Now getting back to my slides, and we'll talk about a more interesting topic. which is application gateways. Now you would ask me, hey, sort of, why do we need so many load balancer as an offering on Azure, right? You have Azure load balancer, you have application gateways, you have front door CDN, traffic manager, and stuff like that. So already, as said, right, each of them are serving a different use case, and there's a proper reason of why do we have these many load balancers. Now, just talking as about just let's keep aside front door and CDN, which are global load balancers. Talking about Azure load balancer and Azure application gateway. Now, Azure load balancer is a layer 4 load balancer, which means it can only direct TCP or UDP based traffic. While application gateway is more like a web load balancer, which is your layer 7 load balancer. It is meant to handle or support WebSocket protocols, HTTP, HTTPS traffic, and stuff like that. Now, there's also an offering which is Azure Application Gateway with Web Application Firewall. What does a Web Application Firewall mean? Web application firewall is a firewall that is advanced enough to protect against you or your resources against your web application vulnerabilities. Think about SQL, cross-site scripting, right? Any sort of web attacks, right? All of those are something that a web application firewall can protect with you with. Okay. Now this application gateway is clubbed together with a web application firewall. So there are multiple offerings that you can choose. You can create an independent application gateway. You can create an application gateway with a web application firewall to suit your specific needs. Now, I'll quickly show you how you create an application gateway. While application gateway is a layer 7 load balancer, we also talked about, it being a regional load balancer. A very important thing over here is it's a platform as a service, right? Which means it has built-in capabilities. You're not managing that load balancer. It has built-in capabilities to auto scale dynamically to adjust your web traffic, and it depends on how do you define the auto scale within the application gateways as well. So again, there are multiple other features and functionalities like connection training, backend pool configuration, and stuff like that, which will show you as I go ahead and share my screen. 1 minute. I think that stopped. I hope you are able to see the screen. Yeah. And I'll go to my Azure portal and I'll show you how do I create load application gateway. Okay. So I go ahead and type in application gateways, and I can create a basic application gateway over here for you to quickly consume that. Okay. So I go ahead and click on create. Now, if I specific resource group, obviously, where I want to store my application gateway as a resource, I'll give it a name as app gateway. Oops. Okay. Now I want to define the region, Central India. Now I want to choose the SKU. Okay, it could be a basic application gateway, a standard V2. Standard V2 has auto scale capabilities. While you can also choose a WAF V2. WAF V2 means it is enabled with the web application firewall capabilities as well. So I'll create a standard V2 as a basic and enable auto scaling. Yes, you can define the minimum instances, which I'll define as 2, and my billing would also be based on the number of instance counts, and I can define the maximum instance. I want it to be zone redundant. What does this mean? So Elena, I hope my screen is visible, right? Okay. The application gateways can be either confined to a specific zone, which means if there is a zonal disaster, your entire application gateway is down. Okay, and that's where Azure provides you the capability or flexibility to define application gateways across multiple zones. You can define two zones or maybe three zones at a time. Okay, so zone 1 and 2 and 3, which is available in Central India. I define the IPv4. I do not need a dual stack, and HTTP2 is enabled. I can configure a virtual network as well. So let me select the existing virtual network, which is my VNet over here, and subnet. So it says network security group, my VNet. Okay. to subnet database. This is not permitted for application gateway to skew. Okay, I will select my subnet. I'm not sure if this also has a network security group. Okay, so I'll just create a new to ensure that I do not have a specific VNet with a network security group. App gateway VNet. Okay, and I define the address space range, the subnet as this. Okay, which looks good to me. And here I go. Now I provide the front end IP configurations. 1 minute. So it's a public application gateway. I'll choose to create a new public IP. Okay. And since the app gateway is zone redundant, so the public IP should also be zone redundant. Then I'll define the backend. So I can define backend as maybe some app service plan, some of their resources. So I really doubt I have certain things to showcase as a backend. Add backend pool without targets. I want to define targets as either virtual machines. So I can have backend pool as virtual machine, either IP addresses or FQDNs. I could also have virtual machine scale sets or app services. I don't know if I really have any app services. Let me just check. Okay, I do have one. And I could also choose, I'm not sure. Okay, I only have a single app service. So I'll choose maybe a virtual machine, which is very odd fashion. I do not want to load balance traffic in an app service and a virtual machine. So I'll just maybe keep it simple over here. I'll just select one single app service. I can have multiple backends, and then I'll go to the configuration where I define how do I want the routing rules to be defined. So over here, add a routing rule. You remember as a load balancer as well, we defined the routing rule. So 1 minute. Let's give it a name as route rule. Priority as 100. The lesser the priority, the more is. Now the listener name is app gateway listener. Okay. This will, imbibe the traffic on the port 80, okay, or it could be 443 as well. I'll make it HTTPS, which is 443, okay. I can provide, I do not have a certificate right now, so let's select 80 only, and which looks good to me. And the backend targets, what is the target do I want to direct the traffic to or route the traffic to? It will be a backend pool. So I'll select a backend target and 1 minute. I do not have a backend setting. Let me quickly create a backend setting. Okay, so what I define over here in the backend pool is if the port, the incoming traffic is on HTTP port 80, I'll also direct the incoming traffic to HTTP port 80, and I enable cookie-based affinity. I disable cookie-based affinity and connection I'm draining for now. Request timeout is fine, and I'll go ahead and define the backend pool settings. Okay, and over here, I think this is good. Skip this and add. Oops.
Saurav, can
And then
you
finally,
again
yeah.
share your screen? Yeah, because I think
Okay.
again
I'll
it's
just
stuck and people can't see the screen. Yeah.
I'll just quickly share my screen. 1 minute. Let me know if you are able to see. See the screen.
Yeah. 1 minute. Yeah. Okay. Yeah, it's up.
Okay. Great. Give me a minute. Okay, cool team. So as we see, we have already provided a configuration for the app gateway, and I'll hit create to spin up my app gateway. So meanwhile, this app gateway spins up. It will take some time. So I'll quickly, in the interest of the time, also cover the next topic. Okay. So we talked about the different networking services, and there's much more to do when we talk about Azure networking. This is just the basic fundamentals on Azure networking. But what we are interested to talk more. Okay. I mean, how do we also the very important thing is also monitoring, right? When we talk about networks or any other resources on Azure, one of the primary thing is also to monitor those resources. Now, when you talk about networking, if anything breaks, okay, and if you are not able to set up a connectivity between two resources, the first thing that comes in is to understand what is the network path and if the network is really able to reach that particular destination. And that's where you need some sort of a monitoring tools, right? And that's where we have a suite of tools on Azure, which is called as Azure Network Watcher. Now, what is Azure Network Watcher? So as we talk about Azure Network Watcher, it's a suite of tools that allows you to monitor, perform repair, or even also helps you visualize a complex network topology across multiple services like virtual machines, virtual networks, app gateways, load balancer, public IPs. Even think about express routes, VPN gateways, and stuff, and a lot more things as well. Now, there are, as I say, this is a suite of tools, right? There are multiple things that are available within Network Watcher, and I'll quickly show it to you as we go ahead back to the Azure portal. So there is tools like connection monitor, topology, which helps you visualize the topology. You can perform network diagnostics using various tools like IP flow verify, NSC diagnostics, next hop, effective security rules, and stuff like that. I know, that this really needs a demonstration, and that's where I'll directly go to the Azure portal. So let me get back to the Azure portal and quickly show it to you. I see the deployment is still in progress. So meanwhile, in the interest of the time, I'll just go to my next browser tab and I'll type in network watcher. Okay. Now imagine it as a single destination for performing any sort of a network diagnostics, network monitoring, or even network troubleshooting. Okay, so I enable network watcher. Now these network watcher set of suite of tools that over here that you see would also require you to collect some network level logs. How does it show that there is a connectivity between two or not? It's always capturing some network logs, right? And for the network logs in Azure is called as flow logs. Flow logs could be at an NSV level. It could be also at a virtual network level as well. So I'll quickly start out by the monitoring services. Okay, so let's say you want to view the topology that exists in your current environment, right? So okay, VNets. I'll select for VNets. I'll select any other services that are there, and I'll quickly show you how does it look. So primarily all my resources in my subscriptions are based in Central India and South India, and you see that there are a couple of DNS zones as well. There could be other resources as well, which could have been easily shown over here. Okay, let's say I just want to show virtual networks. Where is my virtual network? I do have an app gateway as well. Let's see that. Load balancers, VWAN. I don't think so. I have a VWAN. Let's quickly check. And virtual hubs. So you see, the resources are primarily spread in my Central India. And since I set up a virtual network peering, it does shows that there's a connectivity between the virtual Central India to South India region, right? So over here, you see my VNet and the SI VNet that we had configured is connected. Similarly, there's a Contoso hub, Central India to Contoso hub, South India. So yeah, this now really helps you in a complex environment. This is a quite simple sandbox environment setup, but in a complex environment, I really need a visualization tool to see what are the resources that are existing and how things have been configured, right? So that's one of the things. While also talk about the connection monitor, the connection monitor helps you collect logs and also monitor the connectivity between multiple resources. Okay, I mean, I can show you the setup as well, but I'll just quickly go to the traffic analytics. Okay, now in the traffic analytics, what is this? So let's say there's communication between multiple applications, and there are multiple resources, right, that is communicating. All of those traffic and how is it traversing? Is there any packet loss or anything is being visualized over here in the traffic analytics? Just a quick reminder, the topology was to show your network connectivity, while traffic analytics shows how does the traffic traverses across multiple regions or sub-regions or even resources as well. Okay, so I'll just quickly create, I selected, and there is a log index workspace that I had configured. I'm not sure if there's a data to it. Just let's quickly check. So we could not find the data since I created it just a couple of minutes back. But I mean, I can show you how a traffic analytics looks like on Azure. Analytics on Azure. So I'll just quickly go to the documentation. I'll show you how does it look. So you can see the entire connectivity across resources. I mean, be it an express route, a VPN gateway, multiple VNets communicating between each other, and all those things. Every traffic that goes through is being captured in some sort of a flow logs. Okay, there's a way that we capture the flow logs, and you need to configure it. You need to store it in something called as log index workspace that stores your logs, and that's where, based on those data, is being pulled up and showed in a visualized format. Now, when you want to perform network diagnostics, okay, there are set of tools that are available over here. One of them, which is very interesting, is IP Flow Verify. Now, I want to see the connectivity between two machines, a source. I want to see connectivity from my current network to a target resource, let's say a virtual machine or any other resource, over a particular protocol or direction. I can use this tool to check if I can really connect over it. Think about it as maybe a Kubernetes cluster or a virtual machine that is a public IP, and I want to test out my connectivity. Okay, so that is something that you can use. You can also provide your own remote IP address. Let's say you want to define where do you want to originate the traffic from, and what is your target resource. Now, I also talked about network security group rules, right? You want to identify how are these rules effective? What are the rules getting applied to? Do you want to really check if the rule is getting applied to or not? And that's where you can use NSC diagnostics. So you can define a set of target, a source and target, and you can check is that traffic being allowed or disallowed. Now, I mean, there are times when we create multiple security rules within the network security group, and we really don't know which takes precedence because there could be overlapping rules as well. That is where you see have a rule. I mean, you have a tool called as effective security rules, right? Wherein you define what are the exact set of rules that are taking into precedence or that are effective in a particular NSG. You have something called as next hop. Just imagine you define something called as user defined routes, UDRs. Okay, now these routes are configured like this, that hey, if any traffic is going to my public internet, it should always go through a firewall, and that is where I define a next hop as my firewall. I want to check what is my next hop for a particular traffic that is originating from a particular resource, maybe a virtual machine or some other resource. So I can define my virtual machine, I can define the network interface, I can define the source IP and the destination IP, and I can check what is the next hop to that particular destination IP for that particular destination IP. If there's an UDR, it will show me the next hop. Okay, so this is really effective to check if a particular traffic is really traversing through a firewall or maybe some proxy or something like that. Okay. You can also use connection troubleshooting or packet captures. I mean, I'll leave this to you to quickly check. Packet captures are usually to identify if there is any packet loss, what was the start time, is there how many bytes per packet are being captured and stuff like that. So you can leverage all of these network monitoring and troubleshooting tools. I talked about the flow logs as well. So you can enable the flow logs over here. As you, if you see, I've said these flow logs are like your network logs being captured in a log analytics workspace. Log analytics workspace is where your all of your logs are stored on Azure, right? So based on these logs only, you would be able to see the connection monitor and the traffic analytics over data over here. So I think that was a really comprehensive, and I know this is a difficult topic to understand. But feel free to reach out to me directly on LinkedIn, or I mean, or any other platform, or even in this YouTube channel, to for any clarification, any question that you would have, and I would love to help you with the same. Having said that, we are already up on time. So thank you so much for staying connected and learning all of us. I'm really excited to see people getting certified on AZ104, and see how mastering AZ104 with Saurav has been a fruitful outcome for you. So really thankful for that, and wish you a good day ahead.
Thank you, Saurav. But before we go, can we take one last question from Surinder? I'll just get that up on
Sure.
screen.
So the question is, can we define rules on network traffic rules on-premise to Azure? A network traffic rule, what do you exactly mean by that? And can you just pop up the question, please? On-premise to Azure cloud. So, okay, in an on-premise to Azure cloud scenario, if you have already set up a VPN gateway between the on-site and the virtual network that is residing in Azure, okay, you can always define a rule at either of the scenarios, and either of the sites. You can define a rule at a virtual network level. You can also define at your on-site level. An on-site would have a different set of resources or network devices. Then you can define your network rule. How should it traverse? Should it traverse from a firewall which is residing in a on-premise, or should it be traversing through a firewall which is residing in Azure and stuff like that? For sure, you can do that, but that would be on your on-premise side. Similarly, on the vice versa, when you define a network rule on Azure, you will be defining it using user-defined routes, and you can configure how does the network need to travel. Is there a hop between the connectivity between the on-premise and the Azure? Yeah.
Okay, great. I think that's about it. And thank you so much, Saurabh, for hosting this session. And thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions. Also, we would appreciate your feedback on today's session. Please scan the QR code and do share your feedback. Today's event ID is 25255. Also, please feel free to use the Learn module link. This will give you access to additional resources to take your learning further. Thank you all once again and enjoy the rest of your day.